Good morning, guys. Happy Thursday. This will be a nice, easy lesson for us today. Not much work, and you'll get ready to enjoy your weekend. I hope everybody's doing well, is healthy and safe. Today, we're going to be learning the difference between looking at charts and differentiating between if it's an exponential or linear data. We graph both of exponential functions and linear functions using tables, but today we're going to determine whether it's exponential or linear looking at the data in the table. Okay, so we have our x and our y values. If we see in our x values as we go down, each time we go down, we are adding 1 each time. So 0 to 1, 1 to 2, 2 to 3, 3 to 4. So we're going up by 1 each time. If we look at our y values, each time we go up from a 6 to a 9, a 9 to a 12 to a 15, a 15 to an 18. We're going up by 3 each time. So we're adding 3 each time. There's no way that we can multiply to get from a 6 to a 9 and using that same number to get from a 9 to a 12 and so forth. So this data is called constant, because both the y and x values have this is called linear, because both x and y values have a constant rate of change. Okay, so this is a linear chart. We're using addition on both sides of the chart. This example, okay, whether it's linear or exponential, your x values are always going to be at a constant rate. In this case, they are going up by 1 again each time. But if we look at our y values, to get from 1 to 4, yes, I could add 3. But if I added 3 to 4, it would give me 7, not 16. So I got to think that we're going to use multiplication. So what number times 1 will give us 4? Well, we know that number is 4. And then if I do 4 times 4, what do I get? Well, I get 16. And 16 times 4 is 64. And 64 times 4 is 256. So on an exponential chart, we're going to have our x values are still going to be using addition or subtraction, but our y values are going to be using multiplication. Okay? So this data is called exponential, and I'm not going to be able to fit it in here, so I'm just going to write EXP, because the x values have a constant rate of change, while the y values are changing by a multiplied rate of change. Okay, and I just put 2 more examples here to show you. Okay, if we're looking at our x values, from -2 to a -4, from a -4 to a -6, from a -6 to a -8, and then to a -10, we're subtracting by 2 each time. This is a constant rate of change for our x values. And then if we look at our y values, to get from a 3 to a 5 to a 7 to a 9, and a 9 to 11, we're going to be going by adding 2 each time we go. So this is also a constant rate of change. So if on our x values and our y values are constant rates of change using addition and subtraction, this is a linear function. To take a look at this one, from a -4 to a -2 to a 0 to a 2 to a 4, it is a constant rate. And each time we go, we're actually going to be adding 2 in this example. Remember, we said that our x values are always going to be at a constant rate. Now let's look at our y values. How do I get from a -2 to a -4? And then from a -4 to a -8, -8 to -16? Well, we're not using subtraction or addition, but we're going to be multiplying here. 2 times what gives me -2 times what gives me -4? Well, we're multiplying by 2, because 2 times -2 is -4. -4 times 2 is -8. -8 times -2 is -16. And -16 times 2 is -32. All right? So this is a multiplied rate of change. So this is an exponential function. Okay, should be pretty easy today. This is page 9, your work is on page 10. You have 3 examples and then 1 multiple choice question. Okay, any questions, message me in the remind. Continue with the good work. I hope you guys have a good weekend, and we'll speak again on Monday.